2.3, you're going to learn how to solve equations. And if you read that, you're going to learn how to solve quadratic equations. And you're going to learn how to solve quadratic equations, all the different ways we learned in Algebra 2 just in one section. That's why this is called college algebra, because it's a fast-paced class. A quadratic equation has a degree of 2. Usually you get 2 answers, because you're solving quadratic equations. Ax squared plus bx plus c is called a quadratic equation. And we're going to go through all the different ways we solve quadratic equations. The first way that we solved a quadratic equation is by factoring. Okay, when you factor, this is very important. When you factor, you must have 0 on the right-hand side. You must have 0 on the right-hand side in order to factor. The first thing I'm going to do is take out the greatest common factor, which is a 4. So I have an x squared minus 18x plus 81 equals 0. So I took a 4 out. Once I took a 4 out, now I'm going to factor. 2 sets of parentheses. I know an x goes here and an x goes here. I need to figure out factors of 81 that will give you a negative 18 in the middle. A negative 9 and a negative 9 are your 2 answers. I'm trying to solve for x, and I know that there's 2 answers. Notice that this one does not have an x attached to it, so you don't have to set that one. I just have to set x minus 9 equal to 0, and I set x minus 9 equal to 0. And it just so happens that this problem, you get the same answer. But remember, you need to get 2 answers because a quadratic equation has 2 answers. It just so happens that they're both 9. Okay, here's another one. Again, you had this in Algebra 2. The first thing I'm going to do is I am going to put all 3 of these fractions together. And how do you put all 3 of these fractions together? You need to have a common denominator. You cannot add or subtract fractions without a common denominator. The common denominator is an x and an x minus 2, and an x and an x minus 2, and an x and an x minus 2. Again, if I'm going too fast, you can always shut it down, rewrite it, and then turn it back on again. But I'll wait for you to write that down. And this is equal to the same negative 6 over x squared minus 2x. Okay, look at the old denominator and the new one, and that one's missing an x, so that's why it's 5x squared. I have to multiply the top by x. The middle one's missing x minus 2, so that's why it's 3x minus 6. And the last one's missing it all, so I have to multiply 2x times x minus 2, which ends up being 2x squared minus 4x goes there. I'm going to put it under 1x minus 2 because that was the point of that. The point was to get a common denominator, which was xx minus 2. How many x squares do I have on the top where I can put this one and this one together to make 7x squared minus x minus 6 equals a negative 6 over x squared minus 2x. And if you're in college algebra, you should notice that this one down here and this one down here are equal. If I took out the GCF, they're exactly the same, which will save you time. Cancel out and cancel out. So we have 7x squared minus x minus 6 equals a negative 6. Some of you will try to factor this, but you cannot factor until there is a 0 on the right-hand side. You can never factor a quadratic equation unless there's a 0 on the right-hand side of your problem. They do have a GCF in common, they have an x, so I'm going to take a 7x minus 1 equals 0. I know I need two answers. One is x equals 0, and the other one is 7x minus 1 equals 0. So 7x equals 1, and x equals 1, 7. Those are my two answers to the problem. One more of those, I think. Yep, one more factoring. Again, I just want to do another one. Let's just do one more. You cannot add these together. They don't have the same common denominator. So I'm going to make them the same. I think you're going to see it look like this on the test. This is what you're going to see on the test. The first thing I would do is I would put the x over 1 so it looks like that. And now you're going to find a common denominator on the left-hand side, which is equal to a negative 4, which is equal to x. I don't have to do anything to that one, but I have to multiply this one by x, and that's why there's an x squared. So I'm going to have a 3 plus x squared on the top over an x equals a negative 4, and I'm going to put that one over 1. I have a proportion. I have a fraction equals a fraction. I'm going to cross multiply, so I get 3x squared equals a negative 4x. A quadratic equation is degree 2. I have to bring everything over to one side. I have to bring everything over to one side before I can factor it. Factors of 3 are 3 and 1. So x equals a negative 3 and x equals a negative 1. You should check it, because remember, you can never have 0 in the denominator in math, but when you plug x, a negative 3 or a negative 1 into the denominator, it does not turn out to be 0. So I can keep it. Are these two equations equal, yes or no? Are these two equations equal, yes or no? And the answer is no. This is a quadratic equation. All quadratics have two solutions. X squared minus 25 equals 0. Remember, quadratics, in order to factor, you have to have 0 on the right-hand side. This is x minus 5, and this is x plus 5 equal to 0. So x equals 5, and x equals a negative 5. This one is degree 1. That's a linear equation. They only have a degree 1. So this one is only x equals 5. So no, they're not the same. Are the two equations equal? They are not the same. Okay, we are done factoring. The second way to solve a quadratic equation is just alienating the squared part. Just alienating the squared part by dividing both sides by 16. This is a different way to solve it. So I divided both sides by 16. And now what I'm going to do is I'm going to square root both sides. Because whatever you do to one side, you can do to the other. So x is going to equal, here's the stickler. If you do it this way, you got to remember, whenever you do a quadratic equation, all quadratics have two solutions. So don't forget the plus or minus sign. And you learned what to do if you see the square root of a fraction. Miss Cho says to split it up into separate ones. The square root of 49 is 7, and the square root of 16 is 4. The answers are plus or minus 7/4. Same thing with this one. You don't need to factor it. Some of you are going to try to multiply this out, bring the 31 over. No, you just have to square root both sides. That's the quicker way. What's the square root of x plus 4 squared? Just 1x plus 4, which is equal to plus or minus the square root of 31. And then all you're going to do is subtract 4 to both sides. A negative 4 plus or minus the square root of 31. And that's how you solve the second one. I'll just do another one. Let's say it's that x plus 1 raised to the second equals 18. One more. All I'm going to do is square root both sides. That's okay as long as you do it. The square root of x plus 1 squared is x plus 1. Don't forget the plus or minus sign because you need two answers to your problem. 18 is made up of a 3, and a 2. That reduces to 3 root 2. X is equal to then a negative 1 plus or minus 3 root 2. So that's the second way to solve a quadratic equation, is by square rooting both sides of your problem. A lot of kids forget that way, and it's on the ACT, so don't forget that way. The third way to solve a quadratic equation is completing of the square, and you had this in Algebra 2 last year. Here are the steps. Your A value needs to be 1. I'm just going to put it up here, you guys. Your A value, or the term in front of the x squared, needs to be 1. You need to get rid of your C value by bringing it over to the other side. You need to take half the B value squared and add it to both sides, and then you need to solve the problem. So this is called completing of the square, and you had this last year. So here we go. We learned how to solve a quadratic equation. The first way we learned is by factoring, and we just went over that. The second way was square rooting both sides of your problem. That was the second way. And if you don't remember factoring or square rooting both sides, you might have to watch this set of notes over again. The third way is completing the square. Completing the square. Okay, so in this problem right here, x squared minus 8x plus 11, you can't factor anyway. There are no factors of 11 that will give you a negative 8 in the middle, so you can't do it by factoring. You can't do this one by square rooting both sides of your problem, because you would have to alienate the square, and you can't alienate the square. So you can't do it by the second method. So they invented the third method called completing the square. So we're going to do the third method, and we're going to go through the steps. The first step is the A is equal to 1. Yes, it is. The A value is equal to 1. Bring the C value over to the other side. So the C value in this problem is 11. So I'm going to bring it over to the other side by subtracting 11. You did this in Algebra 2, whoever your teacher was. You had this in Algebra 2 last year, or pre-calculus if you had pre-calculus. Okay, I talked about the A value being 1. That's done. I talked about the C value, bringing it over to the other side. That's done. Now we're going to do the B value. Take half of the B value. What's half? What's half of a negative 8? Isn't half of a negative 8 a negative 4? Then once you get the negative 4, you have to square it. What's a negative 4 times a negative 4? Doesn't that turn out to be a positive 16? You always are adding it, because whenever you square something in math, it's always a positive. A negative 11 plus 16 is 5. I can factor this. That's why it's called completing the square, because I can make this x minus 4 and x minus 4 the factors of 16 that will give us a negative 8, or x minus 4, which is the same thing as x minus 4 squared equals 5. I don't know if you'll think this is cool, but completing of the square, I did factor. Right there I factored, and I am going to square root both sides, so I am doing the first two steps, but I can't do the first two steps, or the two ways, until I do something with the A, I do something with the B, and I do something with the C. X minus 4 is equal to plus or minus the square root of 5. So x is equal to 4 plus or minus the square root of 5. Final answer. Okay, let's do another one. This is a little bit more difficult. You'll see in a minute why it's more difficult. Okay, the A needs to be 1, so I have to divide everything by 4. So I get x squared plus 5x plus 13/4 equals 0. Whenever you do completing of the square, you must work with fractions. Decimals are not allowed in doing completing of the square. You cannot use decimals when completing of the square. Okay, why is this one more difficult? You'll see in a minute why this one's more difficult. I made my a value 1. Now I'm going to get rid of my c value by subtracting 13/4 to both sides. Okay, now comes the b value. I have to take half of 5. Half of 5 is 5 halves. I can only use fractions in completing up the square. I cannot say 2.5. You will get it marked wrong on the test if you tell me that it's 2.5. Completing of the square is done using fractions. Half of 5 is 5 halves. After I figure out what half of 5 is, I have to square this number. 5 times 5 is 25. 2 times 2 is 4. This is what I add to both sides. So it's x squared plus 5x plus 25/4 equals a negative 13/4 plus 25/4. If I did it right, I know I need to put an x here and an x here. I need to figure out factors of 25/4 that will give me 5 in the middle. Well, it's 5 halves. I can check it and it works. It makes 5x. Negative 13/4 plus 25/4 makes a 12/4. 12/4 is the same thing as 3. I know that this is the same thing as x plus 5 halves, all of this raised to the second. The whole point of this was to complete the square or make it a perfect square on the left-hand side. Now I'm going to square root both sides. I'm going to get x plus 5 halves is equal to, don't forget the plus or minus the square root of 3. So x is equal to a negative 5 halves plus or minus root 3. And that's the third method, is called completing of the square. And then the fourth method is called the quadratic formula. You've had this in Algebra 1, you would have had it in Algebra 2, and now you get to see it again. ax squared plus bx plus c equals 0. The formula is a negative b plus or minus, I forgot the little minus sign. It's a negative b plus or minus the square root of b squared minus 4ac all over 2a. Some of you remember a song associated with the formula, but that is the formula. And here is the quadratic equation that they want you to use. We are in college algebra. This is the first time I think you have ever seen that the a value in this problem is 5/3. The b in this problem is 3, and the c is equal to 1. You can use these numbers if you like. I am not going to use these numbers. I don't like, it's already a fraction up there. What I'm going to do is I'm going to multiply the whole thing by 3. So here's my original problem. I'm going to multiply every term by 3 because I don't want a fraction. So this ends up just being 5x squared. This ends up being 9x, and this ends up being 3. I like working with the whole numbers. That's just me. Now my a is 5, my b is 9, and my c is 3. Remember, everything has to be over to the left-hand side. And again, there must be a 0 on the right-hand side to also use the quadratic equation. A negative b, a negative 9, plus or minus the square root of b squared. 9 times 9 is 81. Minus 4 times a times c, all over 2a, and a was 5, so that you're going to have a 10 on the bottom. Negative 9 plus or minus the square root of something over 10. 20 times 3 is 60. 81 take away 60 is 21. Can I reduce 21? It's made up of 3 and 7. There's not 2 of anything. There is my answer to my problem. One more thing to talk about. I want to talk about simplifying the quadratic formula. You cannot simplify these two. That is the answer to the problem. If there were to look like this, notice this one has a 2, this one has a 2, and this one has a 2. Then you can simplify it. And you would simplify it down to a -2 plus or minus root 5 over 5. You can only simplify if all three of them have something in common with each other. So, summarize what we learned. We learned what a quadratic equation was. We learned that when you factor, it must equal 0. We learned that you could square root both sides. That's another method. That's the fastest method. The third method is completing the square. That, I think, is the most difficult method. And the fourth method is the quadratic formula. This one right here, why do you have to know completing of the square if you could just use the quadratic formula? The one that I just circled, completing of the square, you can take conics in college. And when you take conics in college, all you're going to do is solve your problems by completing of the square. That's why that's so important.